Hello learners, welcome to Python Revision Tools Session 2. In the last session, we have talked about the important tokens related to a Python program. We discussed about identifiers in great detail. In this class, we will revise about another important Python token called operators and will be building expressions using them. Before starting the session, I must inform you to install any of the Python IDE of your choice where you may compile the example code shown in the session. I would also request you to pause video wherever you want to try writing the code yourself so as to test your progress in the course. As instructor of this course, I will often ask you to pause the video to write code yourself and verify the result. You are always welcome with queries and discussions on our Kaizala platform or during the live YouTube or Skype sessions. So here we go. Operators. Operators are special symbols that convey special meaning to the Python interpreter when used with identifiers. These symbols, when parsed during compilation of the program and a specific operation is being carried out by the Python compiler. There are mainly four types of operators being used in Python, which can be categorized as arithmetic or mathematical operators to carry out calculative tasks such as adding two values or finding the quotient or remainder of a division, etc. Then we have assignment operators to associate an identifier name with a data object. We have relational or comparison operators for comparing two or more values or two objects in Python. Using them, we can compare two integers or strings or boolean values with each other. We will see its use in detail. Finally, we have logical operators which are used to create composite logic by joining two or more relational or comparison expressions. We'll learn about how to create such type of composite logic in this class ahead. Now let us talk about arithmetic operators. To add two values, we must use the plus symbol. And to get difference between two values, we use minus symbol. Both of these operators can be used as binary or unary. That is, it can be used between two operands or may be used in front of a single operand. As shown in the example on the screen, you can see that there is a plus symbol before A, which means that A is used as a unary, plus is used as unary to A. Whereas when the plus is used between A and B, then that is being used as binary operator. The asterisk character or the star is used to multiply two values to obtain product of them. The division operation in Python is carried out using two ways. That is, we have separate operators for floating point division to obtain quotient in the form of floats and also to find only integer part of the quotient, known as floating, using a single front slash or double back front slash respectively as shown on the screen. Sometimes it's needed that we find out remainder of a division rather than finding out its quotient. For this to perform, Python has modulo or modular division operator designated by a percent symbol. One word of caution that you must not confuse this operator for finding out mathematical percentage, because finding mathematical percentage doesn't demands the need of percent operator. It is simple mathematical expression which can be written using mathematical operators. So percent, here percent, the symbol percent is used as a modular division operator. Finally, at times we need to find values like a raised to the power of b. For example, 2 raised to the power of 3 is 8. This operation in Python is called exponentiation and is being done using a double asterisk or double star symbol. So with all these operators in our hand, I would like you to pause the video and perform the calculations using your Python IDE given in the next slide screen. If you don't know how to use Python IDE, then you must see my previous video on demo on how to use Python ideally to write Python programs. You can find the link to this video in the description of this video. So pause and try to practice and realize the result you obtain. So here we have 12 operations to be performed by you. You must open Python IDE or any IDE of your choice and execute these codes and realize the outcome before switching to the next solution video. So I would like you to pause here and do it of your own. Hope you have solved the previous exercise yourself. Now let us evaluate the formula given in previous exercise using a Python IDE. The version of Python IDE can be anything. You can use any version. Now let us solve the first expression, which was 23 plus 78, and as expected it is giving us the result 101. Let us go for the next one. The next one was 18 minus 5. As expected it is giving 13. The result is 13. If I am subtracting a bigger value from a smaller value, as it is given in the next question example, that is 5 minus 34, similarly we will get a negative value. Now let us go for the multiplication operation. 9 into 4, this gives us 36. The next operation was something called none plus none. Now in Python, none is also a value type which designates nothing. So we'll use this particular variable value in future classes. We'll see more about it. But for the time being, let us add two nuns and let us see the result. Now you can see here it is giving that the type error is being reported by the compiler. The type error is an error which comes whenever there is unsupported operand types for a particular operator. So here in this case the plus operator cannot operate between two nuns, and hence the none type and a none type cannot be added with each other. So it clears our concept that two nuns cannot be added with each other. So similarly we can go for the next one, that is none minus none. It will also show the same type of error because the minus operator cannot be done between two nuns. Similar is the case with none into none and none divided by none or none minus none. Okay, so all the mathematical operators plus, minus, into, division are not being supported between none type of values. So you must remember this very crucial point. Now let us come to the next problem, that is 67.0. that is a decimal value. When it is divided with 8.0, it gives us 8.375. So it is as expected, it is giving us the quotient, which is 8.375. Now what happens if I am removing this decimal point? If I am simply writing 67 by 8, the Python compiler evaluates the quotient as integer value 8. It gives us the integer value, though the quotient is 8.375, but it returns us the integer value because an integer divided by an integer in Python always returns an integer quotient. So you must remember that if you want a float quotient out of a division, you must be taking the operands as floats too. Now let us go to the next type of operation, that is between 67.0 modular, that is flooring, that is floor division 8.0. Let us find out what happens here. Now it gives you 8.0. As expected, this flooring operation returns an integer part of the quotient. So the integer part of the quotient is 8, hence it returns 8.0. The 0.37, which is the fractional part of the quotient, is being removed out. Now let us go to the next operation, that is 67% 8. Let us find out what is the value of this particular operation. Now as expected, it is giving you 67, the remainder of 67 when divided with 8. So this is usually simple to understand that the percent operator or the modular operator or the modulo gives you the remainder of a particular division. Now let us go for the exponentiation, that is 84 star star 5. Let us find out what it gives. So you can see that Python compiler is very efficient in terms of calculations. It can do exponential, such a large exponentiation can be done using Python. So it is giving you a integer value for that exponentiation. You should evaluate yourself also what is the value of 84 raised to the power 5 and find out if it matches with the same value or not. Now let us go for the last operation, which is 6 division 0. Now 6 division 0, as you can see, let us find out what is the result of this operation. Now you can see there is another type of error which is reported by the compiler, which is 0 division error. Now why this happens, as we know that nothing, if we are going to take the denominator of a division as fraction as 0, then the outcome will be infinity. So here in this case the 0 division error is reported, hence you cannot take a 0 as a denominator of a fraction. So you have to be very careful about this type of error in future. Now let us come to the assignment operators. The next bunch of operators are assignment operators. In previous class we have seen that assignment operator equal to is used to associate an identifier name with a data object. Let us talk about few more assignment operators, or rather shortcut assignments, which Python allows. The plus equal to operator is a shortcut to add the left side operand to the right side operand and then assign or associate the resultant data object value to the right hand side, to the left hand side identifier name. For example, a plus equal to 5 in the given example on your screen means that to add the current data value associated with 5 and then assigning the newer sum to the identifier a. One should remember here that a being a integer type is immutable. So though a newer value is assigned to it after the completion of assignment, but the initial value of whatever it may be remains intact in memory and is not destroyed. So whatever initial value of a was there, it remains intact in the memory. The same thing can be written as equal to a plus 5. So we can expand this shortcut notation a plus equal to 5 as a equal to a plus 5. Similar are the explanation for the rest of the assignment operators like subtract and assign, divide and assign quotient, etc. So at this point, I would like you to pause the video and use Python IDE to solve the expressions given in the next slide screen. So pause and try to practice and realize the results. So here is the list of 8 steps which you should execute and find the final value of the identifier A. You must pause video here and open your IDLE to execute and react upon the result. So let us understand the previous exercise solution. The first step, which is A equal to 75, this step associates a value A with 75. That is, the identifier A is associated to a value, data value 75. Now let us go to the next step, which is A plus equal to 6. Now what does this step does? Let us see what it gives. Let us see the result of A after this step. It is 81. Now what it does, let us see what it does. The A plus 6 is evaluated, which is 81, which is 75 plus 6 equal to 81, and then this 81 is associated with A. So now A is associated with a new data value 81, de-associating itself with the earlier value 75. But one thing is to be remembered, that the data value 75 is not removed from the memory, as it is immutable. So now let us go to the next few steps, which is A minus equal to 2, A into equal to 2, A division equal to 2, A flooring equal to 4, and A exponential 2. And let us find out what does this does on this, what effect it does on A. So let us do the thing stepwise. A minus equal to 2. Let us print the value of A. It gives the value 79, because what it does, it subtracts the value 2 from 81 and gives the result 79. Again, if I am writing the next step, A into equal to 3, this gives 237. That means what? It multiplies 79. The earlier value of A was 79. It multiplies 79 with 3 and associates the value 237, which is the multiplication of 79 and 3. 237 is associated with A. So the value of A now becomes 237. Now let us go to the next step. The next step is A by equal to 2. Now let us see what effect it does. Now you can see here the value of A now becomes 118.5, because it gives you the quotient, the floating point quotient of 237 by 2. So it divides 237 by 2 and returns and associates the value 118.5 with A. So what does this step does? It calculates the division, the quotient of A by 2 and associates that value with A. So the newer value of A becomes 118.5. Now let us go to the next step of execution. The next step of execution is A by 4, which is nothing but it is flooring. So now the 118 will be applied with the floor operator, and it will be divided by 4 to get the integer quotient. So now let us find out what is the value of A. It gives you 29.0, because this is what is the integer quotient of that division. 118 divided by 4 gives you an integer quotient 29. Now let us move on to the next step. The next step is A star star equal to 2. That means we are going to raise the power of A by 2. So the current value associated with A is 29. So 29 raised to the power 2, whatever will be the value, will be associated with A. So let us see what it gives us. it gives us 841. So the value of A, which was 29, 29 raised to the power of 2 gives you 841, and this 841 is the newer value which is associated with the identifier A. Now let us go to the next step. The final step is A percent equal to 5. Now see what happens to this, the value of A. Now you can see the value of A changes to 1.0. That means what? It finds out, it divides out 841, which was the previous value of A, by 5 to get the remainder. The remainder of 841 divided by 5 is 1, and hence it returns the remainder, the modulo, that is 1.0. So I hope this clears your doubt about this use of these operators, and now you can use these operators in your program while writing the expression. Now, coming to the relational operators, apart from mathematical operations, Python has various operators to carry out logical tasks too. This is done using relational and logical operators of Python. So let us see the list of available relational operators of Python which are used for comparing two or more data values. The relational operators are enlisted on your screen. The double equal to or equal to operator, a symbol, is used to compare for equality of two data values. It must be noted that using double equal to, we can compare for equality of a numeric values like integers, floats, etc., and also for equality of string values. The outcome of any comparison using double equal to operator is always in terms of one of the two Boolean values, that is true or false. If the comparison stands good, then the expression is evaluated as true, otherwise it is evaluated as false. The equality operator, the inequality operator, not equal to, exclamation equal to is not equal to, is used for comparing two data values for inequality. So if the values are unequal, then the comparison results returns true, otherwise it returns false. Like double equal to, it can also be used between many types of data values in Python like integers, strings, etc. As expected, the greater than and greater than or equal to operator are used for comparing values for being greater than the other or greater than or equal to the other. It also results in comparing in terms of true and false. So the outcome of the comparison is always in the form of true and false. Similar is the case for less than and less than or equal to operators. Finally, there are two wonderful keywords in Python which are also used as operators for special comparisons. They are is and in keywords. The is keyword is used to check whether two variables refers to the same memory object or not. The test returns true if the two objects are the same object. Otherwise returns false. The test returns false if they are not same object, even if the two objects are 100% equal in terms of their values. So when you want to compare only the values of two objects and you are not concerned about comparing their memory locations, then you should use double equal to. Otherwise, if you are concerned about the equality of the memory locations, then you should use is operator. So is operator in nutshell is used to compare the memory location of a particular object or a variable. Now let us concentrate on in keyword, which is used to check the membership of a data value into a Python sequence like lists. More specifically, we can say that the in keyword has two purposes. Number one, the in keyword is used to check if a value is present in a sequence, that is lists, range, strings, etc. And the other one is the in keyword is also used to iterate through a sequence in a for loop, which we will see in our future classes. Now that you have understood all the available relational operators, you should attempt the exercise given in the next slide. The exercise has number of statements using relational operators. You must evaluate them and then compare your result with that of the solution ahead. So, I will request you to pause the video.
It's 6:30
Here and attempt the exercise given in the next slide. Pause the video and attempt the above 23 numbers of exercises. You should send your answer to me on our Kaizala group. The solution of these will be discussed in the coming up slides. So pause your video, practice the exercise, do it on your idle and come back. Let us quickly see the solution of our earlier exercise. The first example to solve was the code A is equal to kkg, B is equal to kkg, and A equal to B. Now if we are comparing two strings, the equal to operator will hold good. Let us see what is the result. It is giving us false. Why it is giving us false? Because we have two separate strings. This kkg and this kkg capital are not equal, and hence the result is false. Coming to the next question, A is equal to 0, B is equal to 1, and A equal to B. As you can see that there are two values A and B, and both of them are different values, A being 0 and B being 1. So the result will be false. Let us come to the next question in the series. A is equal to 0, B is equal to 0.0, A is equal to B. Now you can see here A is a integer value, B is a floating point value, but both of them are having same or similar values, that is 0. So let us see what happens when we are going to compare two different types of data, one being integer, another being float, but having similar values in it. So it is giving us true. So it doesn't matter whether you have 0 as integer or 0 as float, both of them are similar in nature. Now next, let us come to the next question. True is equal to true. As expected, it is giving true because a true is always equal to a true. We are comparing two truth value, and hence the result is also true. Now let us compare true equal to false. As expected, these are two different Boolean values, one being true and another being false, and they are not equal. And since they are not equal, the equality between them will give us a false value. Now let us compare the next question. 1 equal to 5. Now 1 being a data object, 5 being another data object, and both of them are not similar, this will give us false. 1 equal to true. Now here 1 being an integer value and true being a Boolean data value, data object, both of them are different data objects, different type of data objects, one being integer and another being Boolean. Let us see what is the result of this comparison. This is also giving you true. That means in Python, internally the Python takes the integer 1 as true. It considers integer 1 as true, and hence this result This comparison result is always true. So you can conversely use true and 1 with each other, because internally Python takes 1, the value 1, as true. Now let us find out the next question, that is 0 equal to false. So if Python takes 1 as true, this should be also true. So hence it is true, and 0 is taken internally in Python as a boolean false. Now next, let us come to the next question. 15 is equal to 15.0. Now here there are two similar values, and we have one integer and another we are comparing it with a float value. So now let us see, it is always true. So it doesn't matter which type of value you are comparing. If the content is equal, if they have similar type of values, then the outcome is true. Now let us compare 230.89 equal to true. Now here let me tell you that 230.89 is a float value, true is a boolean value, and we are comparing them together. We have seen earlier that 1 being an integer or 1.0 being a float, when compared with true, it gives you true, because internally Python takes 1 as true. But whether the Python takes other integer values like 230 or float values like 230.89 as true or not is a matter of concern, and it is not taking it as true. So any other value other than 1, any other integer or float value is not considered to be true in Python. Now let us come to the next question. We have a string called Kamal, and I'm going to compare it with true. Now let us see the outcome. The outcome is false, because Kamal is a string value and we are comparing it with a boolean value, and it does not have any comparison, so the result is false. Now let us come to the next question. We have an empty string and we are comparing it with false. Whether an empty string is equivalent to false or not, let us see. It is not. So that means an empty string, though it is empty, but cannot be compared with a false value, a boolean false value. So you cannot compare an empty string with a false or boolean false value. Now let us come to the next question. Kamal is equal to, a string Kamal is equal to false. We have compared Kamal with true and we have got false. That means the comparison does not stand. Now let us compare that Kamal value with false and see what is the result. It is also false. That means a string value cannot be compared either with true or with false. Both of them is giving false. Now let us go to the next point, that is, next question is, we have a list of values 7, 8, 9. Let us compare it with 7, 2, 3 and 4. These are the two list of values. Let us see what is the result. So the left hand side list is having 7, 8, 9. The right hand side being having values 2, 3, 4. So let us see what is the result of this comparison. It is giving you false, because the left hand side values are not equal to or similar to the values which are present in the right hand side. So let us go to the next thing, that is 7, 8 and 9, and let us compare it with a similar type of thing like 7, 8 and 9. So both of the lists are having similar values in similar positions. So let us compare them, and we are getting true. So that means what? If you have two lists having similar type of values at same positions, then the comparison is always true. So the comparison stands true. Now let us go to the next question, which is 7, 8, 9, and here we are going to compare it with is operator or is keyword, and this is again 7, 8 and 9. So we are comparing two similar type of things, 7, 8, 9 with 7, 8, 9, but here this time, previously we were using equal to, but this time we are using is operator. So let us see the result. The result is false, which means that, why this is false? Because in this case it was true, because the internal values of the lists were compared to with each other and it is found to be similar. But here in this case, as we have discussed in our earlier lecture, that is operator is not to compare values. It is used to compare object references. That means the address or the location of the object where they are created. Or rather we can say that it is used to compare the L value of the objects, means location values of the object. Hence, these two lists 789 and 789 are created in two different locations, and hence they are not equal a location wise. So hence this comparison results into false. Now let us go to the next question, which is 0 equal to none. So whether a 0 is can be equivalent to none or not, let us see. It is giving you false. So none and zeros are not same. They are not same. So let us go to the next question. Empty string compared with none. So empty string compared with none is also false. You cannot compare an empty string with none. So none is always none. It is never compared with anything else. So let us go to the 7 is 7. Next question is 7 is 7. Now 7 is 7. Let us find out what is the result. Now in this case it is true. Here in case of list it was giving false, but in case of immutable data values like 7 it is giving true. Because why it is true? Can you imagine why this particular comparison is giving true value? It is due to the fact because 7 is created once in memory, and right hand side 7 is never created. It is using the same 7 which is created in the memory, because they are immutable data values. But in case of lists as we know, they are what? They are mutable data types or mutable data objects. Hence they are created, every time they are created in separate memory locations. Not the same memory location is being used as in case of immutable data objects like integers. So here 7 is an immutable data object. 7 compared with 7 is comparing both the values exist in same location. So the location wise they exist at same place. Hence this comparison is found to be true. Now let's find out 7 is 8. Now this is giving you false, because this 7 is a different integer which is created in different memory location, whereas 8, which is a different value, is again created at different location. And when we compare these two locations, their IDs are not same, their L values are not same. Now let us go to the next question. A is equal to 7, then B is equal to 7, and then we are writing A is B. So we have created two values, A with value 7, B with value 7. So two variables, two identifiers of immutable type are being created, and they are compared with is. So can you guess the result? Yes, you have. I think you have guessed rightly. That is coming to be true, because as earlier, this 7 and this 7 are being created at same place because they are referring to the same memory location. Here in this case also, since A is earlier created and associated, A is earlier associated with a created data object 7 which already exists in memory. So Python compiler will never copy the same thing again in memory. If it is required, the location of the 7 will be referred and will be associated with the identifier B. So when these both identifiers are being compared, their memory addresses are being compared, as that is true with the case of is operator, and hence the result is true because both exist at the same place and same memory location. Now let us come to the next question, which is none. String none is equal to none. So this is false, because none, when it is enclosed within single quotes, it does not have any special effect. It is not treated as a special data value none. It is rather treated as NONE, which is a string. So string when compared to none is always false. Now let us come to the last part, that is last question, that is none is equal to none, and now these two are same data values, and hence the result is true. So I hope the example here have given you a glimpse of what is happening behind the scene when we are comparing immutable data objects, when we are comparing immutable data objects, and we are comparing immutable data objects with mutable data objects. And we are comparing different values like none, and we are getting used to different type of operators like double equal to or single equal to or is operator. I would request you to practice more with greater than, less than, greater than equal to, less than equal to, and not equal to symbols, because we have not covered it here. So I will request you to go through the exercises, more exercises given in the textbook, and solve them, and reach me again if you have any doubt. We will talk about it in Kaizala. So now coming to the logical operators. Often during the course of writing program, we need to join one or more logical or relational expression to build a composite logic. For example, to check people's age, which lies within the range 50 to 70, we must make at least two comparisons. That is, first we must check whether the age is greater than or equal to 50, and then we should also check whether the age is less than or equal to 70. When both of these checks hold true together, then only we can say that the age lies in between 50 to 70. So this specific example demands that the two necessary conditions must be checked to stand true at the same time, and hence there is a need of logical operator between these two conditions to hold true together. In Python, we have three basic types of logical operators, and they are not, and or. The not operator's task is to invert any logic to its opposite logic. That is, not makes a check false if it is standing to be true, and vice versa. The OR operator is needed to check whether any of the logic out of many relational logic holds to be true. If so, the combined outcome of such a composite logic will stand to be true. Otherwise, if all the constituent relational operators are false, then the combined logic stands to be false. We must be well conversant with all these logical operators because it allows us to create complex logical expressions in Python programming ahead. Let us see one small code example to understand the use of logical expression in the coming slide. The example code here demonstrates the use of logical operators like and, or, and not. Let us see the code example. In this line we have declared three variables x, y, z, and we have associated or initialized it with values 8, 9, and 10. This is called packing of variables or packing of identifiers in Python, where in the same line you can write many identifiers separated by comma and associating them with multiple values separated by comma. So this packing and unpacking concept is there in Python. Now let us write one relational logic over here, such as x less than equal to y and y less than equal to z. Now the outcome of this expression is true, as both of the conditions x less than equal to y and y less than equal to z are evaluated to be true, and since both are joined using AND operator, the composite outcome is true. Now let us make a small change in the above expression and see what difference it makes to the outcome. So we have three expressions, x less than equal to y and y less than equal to z, and we, apart from the above two, we have added one more relational expression, z less than equal to x. Now we can see here that the first two conditions are evaluated to be true, as we have seen in step number 1. Now the last condition, z is less than equal to x, here stands that the value of z is 10 and the value of x is 8, and we are evaluating z is whether the z is less than or equal to x or not, which is false. So let us find out what is the composite outcome of this logic. The composite outcome is false. The outcome is false as all the relational comparisons are evaluated to be true. The first two comparisons are evaluated as true, but the third one is false. Hence, the whole expression outcome joined using AND operator becomes false. Now let us see one more code example to understand the use of OR operator. So I am writing x greater than equal to z or y less than equal to z. So these are the two expressions here. The first, and let us see the result first. The outcome is, the composite outcome is true. The first expression, x greater than equal to z, is evaluated as false, but the second expression is evaluated to be true, since y is less than equal to z. The value of y is 9, which is less than equal to z, that is 10. So the second expression is evaluated to be true. Now since a OR logic operator is used to combine the outcome of both expressions, it will be evaluated as true as one of the expression in the composite logic has already become true. So since the second expression has already become true, the whole composite logic becomes true. Now let us write and see the use of NOT. Now you can see here that we have an expression called x less than equal to z, and we have put not before this particular expression. Here the not operator is acting as a unary operator because it has been kept before the operand. The operand is x less than equal to z, that is operand for not. So not is acting as a unary operator. Now let us see the effect of not over this. Now this becomes false. Why this is evaluated as false? Because x less than z, which is 8 less than equal to 10, is evaluated to be true. But when this not is acting over this true value, it is negating it, so that the composite effect becomes false. Hence the outcome is false. So here is a class assignment for you to do. Convert the four given statements into logical expressions using suitable identifier names, relational and logical operators. One is being done for you as an example. You must attempt the four of them. Post your answer to our Kaizala group so that I could evaluate your answers. Thank you for joining the class. See you in the next class.